Okay, so we move on to bolt analysis, or do you want me to move on to hub? It's just that if I do hub, I'm not sure if I'll be able to make it back to bolt analysis in time. Which would you prefer?
Bolt.
The bolt? Okay, bolt analysis. Right. So bolt analysis is another place where you can differ from your colleagues in their other assignments. So the first step when you come to the bolt analysis is you have to decide what your PCD is. PCD is your pitch circle diameter. And that is the distance between the center of your bolts on one side to the center of your bolts on the other side. Okay, so this region in the middle here is for our hub. Our hub goes inside here. I mean, actually, it's not a separate part, it's all one part, but this is the hub diameter. So obviously, your PCD will have to be greater than your hub outer diameter, right? So if from your hub analysis, from your hub analysis, you find that your hub is, say, 150 millimeters, your PCD will obviously have to be greater than that. Now, your PCD is also somewhere where you sort of use your logic to decide. So this distance to the center of your bolts is up to you guys. And you have to think about accessibility. Remember, these are bolts. You have to use a wrench or a spanner to get in and tighten and loosen these bolts. So you have to give enough space for the operator to be able to fit their hand or their equipment in there and tighten and loosen these bolts. So you can make an assumption about how wide this needs to be. So let's say that this is 50 millimeters. You're going to say that there's going to be a 50 millimeter gap from the edge of the hub to the center of the bolt for the spanner or the wrench to be able to fit inside. Now, if we have 50 millimeters this side, that means we also have 50 millimeters the other side. So our PCD is actually 150 plus 50 times 2. So our PCD comes out to be 250 millimeters. And our PCR, or pitch circle radius, is half of this. So 125 millimeters is your PCR. So that's the first step when you do bolt analysis. You have to make an assumption about the PCD. A logical assumption, right? You don't want to leave this gap too big, because if you make it too big, then like if we would say this is going to be like 100, that's a little bit excessive, because now your flange is very, very big and your part is big. And like I said, you have to find the balance between cost and functionality. So choose a logical number for the distance. You can do a bit of research into that as well if you want. But generally around 50, 40, 50 plus minus 10 millimeters is a good bet. All right. Now we move on to the calculation. There are two ways you could go about it. Yes.
We did 50 times. There's the distance above the bolt and below the bolt.
Sorry, Jason, I can't quite hear you.
So why did you did 50 times 2?
Why did I multiply 2?
There's the distance above the bolt and below the bolt.
Distance from the center of the bolt to the other bolt is the PCD, yes. Okay. So there are two ways you can go about calculating. There, you could either say the number of bolts, so state number of bolts, and then you have to solve for the size. Or you could state the size and solve for number of bolts. Okay, there's two ways you can go about it. So if your group decides, okay, we want to use 4 bolts, then you will have to try and solve for the size of each bolt. And if you say we want to use M12, so if you go back to the table that's given in the assignment, if you say we want to use M12 bolt, then you have to solve for how many bolts, how many M12 bolts do you need to be able to transfer that torque, transfer that power without it breaking. Okay. So what type of force again are we experiencing here? What type of force is experienced on each bolt?
Shear force.
A shear force, yes. So we'll be looking at the shear stress, which is equal to the shear force divided by the area. Now the area in this case is the area of each bolt, and each bolt is round. It's got a circular cross section. So the area of a circle is pi r squared. And total area is the total number of bolts you have. So you multiply it by the number of bolts. Okay, that's your area. Your force is, again, you're looking at the torque. So that's your shear force multiplied by your distance. Your distance from the center to the center of the bolt is your PCD divided by 2, or your PCR. So this comes in place of your distance. Your torque is constant. So this is how you solve for your shear force. All clear? So that's why assuming your PCD first is very important, because you need it to do your calculation. Your area is just the area of each bolt multiplied by the number of bolts that you have. The shear stress, if you read the question or read the information, it says the tensile yield strength of each bolt is 240 megapascals, right? But we're not looking at tensile strength because we're looking at shear stress or shear force. So we need the shear strength. And if you read the fine print of your bolt information, it says the allowable shear strength of the fastener is 0.66 times the tensile yield strength. That means our shear strength of the bolt is equal to 0.66 times the tensile strength. And we know that tensile strength is 240 megapascals. So our shear stress is 158.4 megapascals. So this value you will substitute into the formula. And then depending on the way that you go about solving it. So if you do method 1 and you state the number of bolts, your equation will look something like 158.4 megapascals is equal to the shear force, which you calculated here, which is T over PCR, divided by your area, which is pi r squared. R, you're not sure what it is. And the number of bolts, if you say that you want to use 4 bolts, you'll put 4 there, and you will try and make R the subject of the formula. So you solve for your R, and then your R times 2 will give you your diameter. And then this diameter, you will go back to your table and see which one matches up. So if you find that your radius is 5.5, So you do this whole calculation and you find that your radius is 5.5 millimeters. That means the diameter is going to be 11 millimeters. And you go back to the table and you try and find 11 millimeters. Now there's no 11 millimeters. The next size up is M12, so 12 millimeters. So you could say for your bolt analysis that in order for this flange to function properly, we need to use 4 by M12 bolts placed at a PCD of 250 millimeters. Okay, and this is how you would finish off your bolt analysis. This is the statement. Okay, any questions? Any questions? Sorry, guys, I think I lost you there for a minute. Where did I lose you?
M12.
M12. So yes, this is how you would go about it. If you're going to state the number of bolts that you're going to use in your equation, you'll be solving for the radius. That radius, you will then find your diameter. Your diameter, you will check your data table for a size that either matches or the next one up. And in this case, M12 is the bolt that best fits. So you could say that you need 4 M12 bolts placed at a PCD of 250 millimeters for this flange to work. And that is how you do your bolt analysis. Okay, any questions? Any questions?
So what's standing for the 0.66?
What's the reason for 0.66?
Yes, sir.
So if you read your information here, it doesn't give us any information about the shear strength. And like it doesn't give it like this in the table or here in this bit of information. It tells us the tensile yield strength, the tensile yield, but we're trying to find the shear yield strength. But if we read this bit of information underneath the bolts specifications, it says the allowable shear strength of the steel fastener is 0.66 times the tensile yield strength. So our shear strength is 0.66 times our tensile yield strength. So that's why I've done 0.66 times tensile yield will give us our shear yield. Okay.
Okay, sir.
So, okay, guys. Well, any questions before we end this session? Any questions? Okay, well, thank you very much for attending this morning. You've all left your ID number and names in the chat?
Yes, sir.
Okay, great. So thank you very much. Have a blessed week and I'll see you all next week.
Sure.